Hi, my name is Emma Snyder, and this is Lab 2, Lines of Charge. The purpose of this lab is to analyze the information found in the previous experiment in a more accurate context. This lab represents the charge tapes that were created in Lab 1 as lines of charge instead of point charges, as used previously. The end result will be to find the magnitude of the electrical force on one tape by another. The final result was that the magnitude of the electrical force was 4.5018 times 10 to the negative third. The model was created as a computer simulation where the tape was modeled as as charges lined up in a row, and then the electrical field of the tapes were computed at each point and then added together in a loop in the code. The total field strength was computed and an image was output in order to show the charged particles. So here you can see the yellow is the gravitational force, the white is the electrical force, and then those little arrows are all the pieces of the electrical force. So the basic principles used in this lab were Coulomb's law and Newton's third law. Coulomb's law allowed us to calculate the force exerted by an electric field, and Newton's third law shows that one tape is exerting the same amount of force on the other tape that tape is exerting on it. The model that I created had the system as the top charge tape, the surroundings as the bottom tape, and the earth and the initial conditions were that the top tape was suspended at rest with an unknown positive charge. So overall, the experimental portion did not change from lab 1, but basically what happened was we held the top charge tape suspended, and another charge tape was brought near it from the bottom until it levitated, and then that distance at which it started to levitate was taken. This lab was mostly coding based, but here you can see at the top I input my basic values, all the things that I learned from the actual experiment during the last lab. Here are the lines created of charges that will later be measured. The charges are this time organized like the actual shape of the tapes. That's pretty interesting. And then down here is where it goes through the loop and adds up all those charges here. And then it prints out all of the values. So here is the image. As you can see, there's the two lines of tape. Here is the electrical force. These are all forces caused by these charges. And then here you can see that the magnitude of the net electric force is given, as I said before, 4.5010.8 times 10 to the negative 3. And then this is the gravitational force, which isn't actually necessary. And this right here is actually the charge found in coulombs on the top piece of tape. And the bottom piece of tape is on both, actually. So some things about the code. The model was assuming that the charge was evenly distributed along the charge tape. The model and the experimental data had the same distance at which the tape began to float, but the charge was actually unknown in real life, so this model might be a little off. As far as error goes, because the prediction was based on previously collected data, the initial charge of the tapes may have been incorrect, and that could have happened based on basically a difficulty when measuring the distance between the tapes when it started to float. So, in conclusion, the magnitude of the charge on one piece of tape, according to my model, was 5.04 times 10 to the negative 8th coulombs. And the idealizations that we made were that you would ignore air resistance and assume that each U tape was made to have the exact same amount of charge that is evenly distributed along the length of the tape. And as far as the what if question goes, the data when modeled as a point charge produced an electric force of 3.11 times 10 to the negative third, which is different than was stated in the previous slides. And why are these different? When you calculate these, they have different formulas, and therefore these representations have very different values. However, the line charge is likely more accurate as it is closer to the actual shape of the tape, as well as the fact that the even distribution is much closer to what actually would happen in